Hi again, Preposterous, and everyone who's watching the discussion that we're having on the mathematics and epistemology science. And so, yeah, finally I changed my webcam and it seems to work pretty decently right now. Hope it keeps on working like that. So, yeah, the last question that I asked was whether one was able to imagine a shape that wouldn't have any quantity and a quantity that wouldn't have any shape. So, and you came up with two very good answers. That the number 3, for instance, you say that you can imagine this number without assigning it any kind of shape, and I'll come back to this later, but the second example that you took is rather easy to disprove in a sense. We're talking about a blobby shape that you wouldn't assign any quantity to it, but you would agree that this blobby shape would have at least something like a perimeter or an area or a volume to it, right? If it didn't have any of these three things, then I mean it would be nothing, or it would be pure quality in a sense, and no, you wouldn't be able to see it or measure it. So your blobby shape has a shape, and therefore it must have a certain quantity, whether it be volumes, areas, or simple length to it. So I mean, this is really simple. For as soon as you imagine a shape, you have to acknowledge that this shape will you can assign a quantity to that shape. You can measure it or weigh it or whatever you want to do with it, but you will be able to measure it. You will be able to assign it a certain quantity. But now, concerning the number 3, you say that you can imagine this number without assigning any shape to it. But and I thought about that, but when my challenge is, how did you get this idea of number 3 in the first place? Didn't you get it throughout shapes? Didn't you get the idea of the number 3 when you were a kid, when someone showed you 3 bananas or 3 apples or 3 similar objects, and then you get the idea, oh, this is 3? Or you can imagine a line whose length is 3, or you can imagine, you have to assign something to it, this idea of quantity. You can't just say 3. 3, it's an idea, right? It's not something that you can meet like by itself, but it doesn't come alive. It doesn't make any sense if it doesn't have any relationship to the material world, to the physical world, because it deals with a quantity. So then, if like the idea of quantities came from observations, you just observe and you realize that quantity basically comes from multitude, right? I mean, if everything was one, or if you only had one thing, you would never have this idea of quantity. You would have never had any numbers. If you only had one thing, or let's say, I don't know, if you were alone in the universe, you wouldn't count, because there would be nothing to count. So you acknowledge first that there are several things out there. The multitude exists, and the way to measure this multitude is through numbers. But you come to understand this multitude by observation and kind of through a scientific inquiry, in a sense. You acknowledge, you see different things, you acknowledge the idea of difference, if everything were the same as everything else, you wouldn't have any difference, and through this idea of difference you acknowledge the idea of multitude. You know, if there is difference, then there is the number 2 exists. You know, if you take two things and you agree, you acknowledge that, oh, okay, yes, they're not the same, you know, they're different, then you get the idea of 2, right? Then you get the idea of multitude and numbers and everything like that. So it comes from the idea, the acknowledgement of difference, the numbers. But this, the acknowledging that the fact that there is difference, you have to acknowledge the existence of different shapes. You know, you have to be able to see this difference, or to perceive this difference. And the only way to perceive something is through shapes. You know, you have you know, if I show you different things, you have to be able to see them. You know, if you close your eyes and I show you two things and I ask you if they're the same, you won't be able to answer my question. You have to be able to see them, you know, and you have to give them a certain shape. So, and also, you know, taking this subject of mathematics as something purely detached, or something purely different from any other science, I think is wrong, because I mean, it's a mistake, I think, that teachers make at school when they teach mathematics, that you cannot approach mathematics as a science in itself. You know, mathematics is simply a language. You know, it's symbols. That's all it is, and it's symbols that deal with multitude, with quantity. And so these symbols, they help you to translate, in a sense, what you can observe in physics and in science more generally. And maybe I'll leave you with that thought. You know, the etymology of the word geometry